We're very focused in the A4 on recovering and building readiness. In fact, a little over a year ago, we took a critical look at our entire sustainment enterprise, and we asked ourselves, how can we fundamentally shift how we operate inside this enterprise that we call logistics and sustainment. And just over a year ago, then Secretary Wilson and the Chief, General Goldfein, signed that strategic framework, and we've been busy implementing that ever since. So its major lines of effort really are to capitalize on some unrealized capacity in our repair network, moving workloads so that we can improve productivity, reduce costs, and actually, enhance the repair capacity at lower levels. That will also be incredibly important to us in a national defense strategy kind of scenario. It builds a more resilient supply chain, so we're not as dependent on sole sources and single source suppliers, but can build out not just competition, but also then some surge capacity when you think about that national defense strategy scenario. And it focuses on big data. So allowing us to really get after predictive maintenance by really transforming the piles of data that we own into actionable information, and allowing us then to take unscheduled maintenance and turn it into scheduled maintenance. So we're repairing aircraft at a time and a place of our choosing, not where the airplane decides to break, but where we have the resources available to effect a repair in the most expeditious and efficient manner. Same level of competence moving in, that they're proficient and then safe in executing the mission in that environment. So all three of those, I think, will come to play.
Very good. Now, just a couple of minutes ago, you mentioned that command and control is so very important to logistics, especially as we look to future operational concepts like the ACE idea. Getting the right stuff to the right place at the right time is not magic. It takes a lot of data, connectivity, modeling, and control. So how has the logistics community been investing in and preparing for this whole notion of joint all-domain command and control?
Great question. I hearken back to the conversation we had earlier about LOGC2. That is in some ways our component under JADC2. So, JADC2 is having the decision advantage in multi-domain operations. And so in the log enterprise sustainment, we want to have that same decision advantage in order to support multi-domain operations, because sustainment and logistics follows ops. And so we've got to be able to have the sense, orient, and respond, posture, sense, and respond in this realm to be able to support multi-domain operations in the way that the operators plan to employ. And so it's going to come down to LOGC2, and LOGC2 is largely about our log IT enterprise. So right now, we're right in the middle of the process of rationalizing all of our IT systems. We've actually shut down 200 or so of our IT systems, consolidated, rationalized them down, taken that money, that savings, and plowed it into replacement capabilities, data cloud migration, and edge computing, which we think will be absolutely essential to realizing a LOGC2 capability moving forward. So we do capture the data that you talked about. We capture it today. We capture it at a rate that's probably too rapid and too voluminous for any one person or organization to really make sense of in real time. It comes from multiple sensors, multiple sources. It comes from onboard aircraft. It comes from SCADA systems that control our infrastructure, other IT systems, and the like. But that data really is the key to our awareness of what's happening in the environment and what's happening in the broader enterprise, to include at home in the depots and the broader supply system. So, and then once that data is in place, we need to protect it, and we need to be able to share it widely. So protecting it means moving a lot of the data into the cloud or into a data lake environment, which gives us multiple fail-safes for resiliency of that data. Once it's in the data lake, we have to be able to share it. We have to connect the systems. We have to remove the stovepipes between those systems so that the data is available to all, and then be able to fuse that data at a rate that the future fight will demand. And then on top of all that, then we can lay on top machine learning, artificial intelligence that can use its predictive capabilities to tell us where to shift resources, where to shift the fight, if you will, to make sure that we've got the log command and control necessary to support the JADC2 and the operations as the operators tend to employ it.
Well, very good. General Barry, you've been doing a lot of work to transform the maintenance and logistics field to be prepared for the kinds of conflict outlined in the National Defense Strategy. How has the logistics community been thinking about providing support in contested environments? Can you talk to us a little bit about concepts like predictive maintenance?
Sure. So the contested environment, much of kind of what I talked about before, where we know we're going to be in a degraded environment. We know that there's going to be times where we're not going to have perfect comms back. And so that pull system that we used to use of ordering a part and expecting it to arrive won't be possible. So you got to move to a push system in that cyber contested environment. Certainly, putting the data in the cloud and the data lake that we talked about helps with the resiliency to perhaps give us the ability to access the data, even if an adversary tries to deny our use. So all of that in play through all of this as well. But the data is a big part of predictive maintenance. And I'll just tell you that, I continue to believe that predictive maintenance is a real game changer for us as an Air Force. We have long been a fly to fail Air Force. So we'll replace a part only when it fails and only when that part decides to stop working. So the challenge, of course, is that sometimes those parts decide to stop working at the worst possible time, right? It's in the middle of a surge. It's in the middle of a continent that might not have the most robust support that you would want to have in place when an aircraft breaks. So the idea here really is to take the data we already own, the data that's resident in our information systems, or the data that's resident on systems on the aircraft with sensors or things like ACARS or the predictive health monitor on the F-35 is but some examples. But even the information that we have in our information systems, and then putting that machine learning and artificial intelligence algorithms on top of it, and then letting that big data tell us when a part is expected to fail before it breaks. It's going to tell us when it breaks before it breaks. And so now I take a whole bunch of what used to be unscheduled maintenance and I can turn it into scheduled maintenance. Now I get to change the part at the time and place of my choosing, not at the time and place when the part decides it wants to break. So why wouldn't I want to change a C5 thrust reverser, for example, at Travis, where I have the trained technicians, I have the infrastructure, I have the facilities, I have the equipment, rather than let that thrust reverser fly to fail and it fails in Nigeria. And now I've got to generate a whole other airplane with the repair parts and the crew to go fix it. It is a readiness hit. It's a huge perturbation to readiness, right, when you have to do things like that. So we've seen it be very powerful and effective in commercial airlines. We are not a commercial airline by any stretch of the imagination, but there's a lot of power in moving unscheduled maintenance into scheduled maintenance. And we're firmly convinced that it will improve our readiness and improve our combat capabilities by doing so.
No, that's very good. Warren, one last big picture question before we open it up to the audience. For a long time, the entire Department of Defense has prioritized leanness and efficiency, modeling logistics after commercial enterprises that are just in time. In a similar manner, maintenance programs have sought to lean costs by removing skill and manning. In practice, this means closing the base back shops and depending on the OEM for delivery of new spares. Both of these concepts are very dependent on a reliable and responsive logistics chain. But this might not be the right paradigm in a contested environment that you just talked about. Could you share your thoughts a little bit regarding the tension between efficiency and resiliency in future battle space that logistics and maintenance are going to have to operate?
Yeah, you bet. We put a lot of thought into this, right? I think there's a natural tension between the two. I think my predecessors, right, have struggled with this balance between efficiency, cost effectiveness, and resilience and effectiveness of the mission, right? Mission effectiveness, and there's always a tension between the two. So, and the context that you're operating in matters. So, in a counterterrorism fight, where really my supply chain wasn't at risk, my distribution system wasn't challenged, maybe it made sense really to take a little bit more risk in terms of more efficiency on the scale. But clearly, the national defense strategy gives us a different paradigm. And so there are some vulnerabilities there that we think we need to get after, that perhaps rebalance, right, the efficiency and the effectiveness equation as we move forward. So, sole source, single source vendors, they will scale and scope their business to the demand signal that they're being given. I don't for a minute believe that the demand signal that they're going to have during a conflict that the National Defense Strategy envisions is going to be the same as it is in a steady state flying hour program. So how much surge capacity is there really, right? So we kind of think about that in terms of, the efficiency and the effectiveness. But I think we also need to admit that it's not always a binary decision, right? It's not always an either or. There are some things that we can do that really satisfy both parts of efficiency and effectiveness. And as you think about the sustainment framework that I talked about at the very beginning, I think if you went through that and looked at some of the implementation pieces of that we're putting in place, I think you'd see that there are places where we're really doing both efficiency and effectiveness. So I'll give you a few examples. So predictive maintenance, right, one that we already talked about, is one way we become much more efficient by capitalizing on more scheduled maintenance than unscheduled maintenance. But we become far more effective by sending aircraft into the fight that we know are healthy, that have the parts already changed because we changed them before they were going to fail. We know additive manufacturing can increase repair capabilities, and in many cases can be done more cheaply at the same time. We expanded our repair network integration. We know that we had excess repair capacity in the network that we weren't tapping into. And so we're finding ways to tap into that repair network capacity to increase our repair capabilities across the enterprise. And then one I would say that we chose probably effectiveness over efficiency is the one where we don't buy parts that don't necessarily have a demand signal on them for a certain period of time. It's about 18 to 24 months. But we also know that some of those parts are really critical. And so I think as we look forward, we're looking to find ways to purchase those low demand parts, so we at least have them somewhere in the enterprise should it fail, as opposed to not having it anywhere in the enterprise. And then you've got to wait 18 to 24 months for industry to spool up and actually make that part for you. So it's a constant balance, right? It's not necessarily binary, but I know that even though there's no magic bullet, we will continue to operationalize a national defense strategy, probably weight a little bit more toward effectiveness than efficiency. But we know that we're spending taxpayer dollars, and so we'll make the smart trades along the way.
Well, very good. And Warren, thanks again for your time and your insights today. We certainly value the dialogue, and we value your thought leadership and all that you do, and as well as your team and what they are doing to solve the logistical challenges of the national defense strategy. Your portfolio truly is the foundation of combat power projection. So on behalf of the Mitchell Institute and all of the AFA, we thank you and your team for all that you do during this very challenging period of U.S. national security.